So the next lesson will be on percentage composition. So what is percentage composition? Well, percentage composition is the percentage by mass of each element in a compound. And the percent, remember from our mathematics, is the part divided by the whole times 100. Therefore, or so, percentage composition of a compound or molecule will equal the mass of an element in one molecule divided by the mass of that molecule times 100. So here's an example. What is the percentage composition of potassium permanganate, KMnO4? Well, first thing we're going to do is work out the relative molecular mass of potassium permanganate, which you already should be able to do from previous lessons. Remembering it's the sum of the atomic masses, relative atomic masses of all the atoms in that particular compound. So potassium has an atomic mass of 39.1. You have one of them, so 39.1. Manganese has an atomic mass of 54.9. Oxygen has an atomic mass of 16. We have 4 of them, so you must multiply it by 4. That gives 64. So the total relative molecular mass is 158 when you add these numbers together. Okay, so continuing on, we've got the relative molecular mass of 158 for potassium permanganate, so now we're going to work out the percentage of each of the corresponding elements of potassium, manganese and oxygen. So to work out the percentage of potassium, it's simply the relative atomic mass of potassium, because there's only one of them, divided by the molecular mass, which is 39.1 divided by 158 times 100, which is 24.7%. The percentage of manganese, we go to the periodic table, find the relative atomic mass of manganese. It's 54.9. You divide it by 158, multiply by 100 to give 34.8% manganese. And oxygen, remember we've got 4 oxygens, so it's going to be 4 times 16 or 64 divided by 158 times 100, which gives 40.5%. And if we add these together, 40.5 plus 34.8 plus 24.7, it gives 100%. So we're on the right track. So that's the answer for the question about the percentage composition of potassium permanganate. So to further practice this skill, try and determine the percentage composition of sodium carbonate, Na2CO3. So pause the video now, try and work it out, then come back and we'll go through the answer together. Okay. So first thing we're going to do is work out the relative molecular mass of sodium carbonate. So it's going to be 2 times the relative atomic mass of sodium, which is 23. So 2 times 23 is 46. 1 times carbon, which is 12. And 3 times 16, which is 48 for oxygen. So the relative molecular mass is 106. Then we go through the percentage compositions are going to be, for percentage of sodium, will be 46. Because we've got 2 sodiums, 2 times 23, divided by 106 to get times 100 gives 43.4%. The percentage of carbon will be 12.0 divided by 106 times 100, which gives 11.3. And finally, the percentage of oxygen is going to be 48.0 divided by 106 times 100, 45.3%. And again, if you add those numbers together, they shall come to 100%. Right, so next question. Determine the percentage composition of ethanol, C2H OH. So pause the video now, see if you can find the answers, and then we'll go through and see if your answers are correct. Okay, so welcome back. So I did the calculations, and you should have the following percentages for each of the elements. The percentage of carbon is 52.13%, the percentage of hydrogen is 13.15%, and the percentage of oxygen is 34.72%. Okay, another practice question. Determine the percentage composition of sodium oxalate this time, Na2C2O4. Pause the video now, and then we'll come back, and I'm going to give you the answers and see if you're correct. Okay, let's see if you're on the right track. So for this one, the percentage of sodium, I calculated 34.31%. The percentage of carbon was 17.93%, and the percentage of oxygen was 47.76% this time. Okay, so hopefully you're getting these correct. If you're not, you need to go back through the video and your notes and determine where you're making the mistake and correct it so you can improve and get these right when it comes to the exam. Okay, another practice question, this time slightly changing it. Now you've got to calculate the mass of bromine in 50.0 grams of potassium bromide, so a little bit harder. So again, pause the video and see if you get it correct. So I'll be back in a few seconds with the answer. Okay, so that's a little bit trickier, so let's see how you went. So the first thing is you've got to find the relative molecular mass of potassium bromide. So you go to your periodic table, you find the relative atomic mass of potassium and the relative atomic mass of bromine, you add them together, and it gives you the relative molecular mass of potassium bromide of 119.0. So hopefully you got that number from the periodic table and calculated it correctly. Step 2, you work out the decimal of the amount of the amount of bromine in it. So it's going to be 79.9 divided by the relative molecular mass, 119, to give you 0.67. And then all you do is you multiply the 0.67 by 50 grams. So it means that for every 50 grams of potassium bromide, you have 33.6 grams of bromine. So hopefully you got that correct. If you didn't, point out or just focus on the area where you got wrong and go back through your notes and the video and see if you can improve. Okay, the final question, calculate the mass of nitrogen in 85.0 milligrams of an amino acid lysine C2H OH. Now be careful, of course, now with conversions of masses with this one. Okay, just carefully read the question. Okay, so pause the video now, and then we'll come back and see if you get this last question correct. And if you do, you're an all-star. You can go on to the next step. If not, go through the video and see where you made the mistake and see if you can improve. Okay, so just finishing up the last question. So first thing is molecular mass of C2H14N2O2. So if you again go to the periodic table, multiply and add the relative atomic masses, you should have a molecular mass, as you can see from the calculations there, of around 146.2. Okay, step 2, you work out the amount of nitrogen. So you've got 2 atoms of nitrogen, so it's going to be 2 times 14 or 28.0. Divide that by the relative molecular mass to give 0.19, and then it's 0.19 times 85 to give 16.3 milligrams of nitrogen. So hopefully you got that correct. And as I reiterate, if you don't, it's about going through the notes, going through the video, making sure you find out where you made the mistake. If you're still struggling, then come and see me.